In this video, we're continuing our discussion with counting what percent of the data falls within 1, 2, and 3 standard deviations of the mean. Our new problem is about laptop use in middle school. Many middle schools have initiated a program that provides every student with a free laptop or notebook computer. Student usage of laptops at a middle school that participates in the initiative was investigated in American Secondary Education, Fall 2009 edition. In a sample of 106 students, the researchers reported the following statistics on how many minutes per day each student used his or her laptop for taking notes. The mean is 13.2 and the standard deviation is 19.5. So we're going to use that information to answer the next 4 questions. The first part says, what is the minimum and maximum value for the interval x bar plus or minus 2s? So x bar plus or minus 2s represents being within 2 standard deviations of the mean. So we're going to calculate x bar plus or minus 2s. In order to calculate that, we're substituting 13.2 for x bar, and s is 19.5. So remember, this breaks up into 2 separate calculations. Once we're taking the mean of 13.2 and adding 2 times 19.5. So 2 times 19.5 would give us 39. So we're adding 13.2 plus 39, and then we're going to start again with our mean, 13.2, and subtract 39. So when we get these results, we'll know what the upper and lower values are for being within 2 standard deviations of the mean. So 13.2 added to 39 is going to give us 52.2. And starting with 13.2 subtracting 39, I can see that I'm going to have a negative result there, 25.8. Think about if a negative value would make sense for this particular example. So these are minutes that students are using laptops. You can have 52 minutes, but can you have negative 25 minutes? That isn't going to make sense. So that's going to be helpful answering one of the other questions today. So it might be helpful to include minutes here with these boundaries. Now that we've calculated them, for part B, we're going to explain why the distribution of laptop usage for taking notes for these 106 students cannot be symmetric. So for part B, it might be helpful to try to think about what this curve might look like. So I know I can mark the mean. That's x bar is 13.2. And I know that 1 standard deviation and 2 standard deviations would be to the right. So at 2 standard deviations, we have 52.2. And 2 standard deviations to the left, our calculation was negative 25.8. And we can't have negative minutes. So we know that even at 1 standard deviation to the left, if we have 13.2 subtract 19.5, we're going to have negative 6.3. So somewhere between the mean and 1 standard deviation to the left, we're going to have 0 minutes. And that's going to be about right here. That's going to be about 0 minutes. And 0 minutes would be possible. That tells us our measurements all need to fall to the right of this dashed line. There's no way that we can have any measurements falling to the left. So most of our measurements need to fall at the mean by definition. And therefore you can see this is not going to be a symmetric curve. It's going to have a tail to the right, so this will be skewed to the right. And again, the reason why we can't have our curve going any further to the left is because these negative x values represent negative minutes. So for part B, we need to justify not symmetric because minutes cannot be negative. So for Question 2b, the curve will not be symmetric because minutes cannot be negative numbers. For 2c, given our answer to part B, what percentage of the 106 students have laptop usages that will fall within the x bar plus or minus 2s interval? So we have to think about our curve and its shape not being symmetric. So that means we need to think about Chebyshev's rule. And we're using Chebyshev's rule because our curve is not symmetric and we don't really know how much of the data falls within one standard deviation. So according to Chebyshev's rule, 75% of the data should fall within 2 standard deviations of the mean.